Okay, so today is Wednesday, May 6th. Your third exam will be on next Monday, and then when I will get you back your exams by Wednesday, 1 week from today, and on your exams, you will have your overall grade up to that point. So if you remember, your final will be used to replace your lowest test score, and so then you can make the determination whether you want to take your final after I get you back your exam and your overall grade up to that point. So we started this last section on 10.1 and we were working with percents, and so we have some percent problems that we're going to try. So at the Happyville Mall, you buy a pair of earrings that are marked $6.95. After the sales tax, the bill was $7.61. What is the tax rate in Happyville to the nearest tenth of a percent? So this is not a basic percent problem. A basic percent problem has three parts: a percentage, a percent, and a whole. And I gave you two formulas which are equivalent. That if you take the percentage and you divide it by the whole, you get the percent. Similarly, we can multiply both sides of this equation by the whole, and you can get then that the percentage is equal to the percent times the whole. Okay. But we have more pieces than that here. In the context of this problem, the percentage is the taxes that you paid, and that was not given to us. The whole, what we're comparing the percentage to is the ticket price, and that we are given. This is the whole. And so we're also not given the percent. It says, what is the percent to the nearest tenth of the percent? What is the tax rate in Happyville to the nearest tenth of a percent? And so there's a couple ways to do this problem. If we want to use the basic percent problem, we have to go and figure out the taxes ourselves. Not very difficult. We have $7.61 that we paid total. If we subtract the $6.95, which is what the ticket price was, we get 66 cents is what we paid in taxes. So we paid 66 cents in taxes. I'm sorry, forgot the decimal point. So this is the percentage. So then I can just take my percentage, 66 cents, and divide it by my whole, $6.95. And that will then give us a ratio, a percent. And so then divided by $6.95, all of this arithmetic can be done using your calculator. And what my calculator tells me is that the percent will equal 0.09496. But we want it to the nearest tenth of a percent, right? And so then, so that when I ask for a percent, I expect it written using a percent symbol, not as a decimal. So to write this as a percent, we move the decimal point over 2 places. When that decimal point moves there, this will be the tenth of a percent place. And so then, since this is a 9, we're going to round that 4 up to a 5. So my answer is 9.5%. Okay, so there is more than one way to solve the problem, and you can solve this problem in a different way. And as long as what you're doing makes sense, I'm fine with that. But you also have to make sure that you show me your work, right? I can't just take answers. Your test is open book, open note. Please don't go Google the answer on the computer or anything like that. But because if I see work that is not what we went over, um, then I'm going to assume you got your answer by Googling it. Can't do that. Okay, so let's move on. Slightly more complicated problem. A shoe store marks up the price of its shoes at 120% over the cost. A pair of shoes goes on sale for 20% off and then goes on clearance rack for an additional 30% off. A customer walks in with a 10% off coupon on all clearance items and buys the shoes. Express the store's profit on these shoes as a percentage of the original cost. Okay, so express the store's profit on these shoes as a percentage of the original cost. Again, your book likes to use percentage when I think they should use percent. Express it as a percent of the original cost. So we want to compare the store's profit to its original cost. There's a lot to keep track of here. Okay, so let's say that our original cost, we were not given that. Let's call it C. If you prefer, as I did in your video, you could say, okay, let's say it cost $100, right? So give us a nice round number. But let's just call it C to help us get comfortable with variables, right? Now, a shoe store marks the price of its shoes at 120% over the cost, right? So then you're going to go through a 120% increase. Now, it wasn't until later that I gave you this formula, but anytime you go to a percent increase or a percent decrease, your new amount is equal to your original amount times 1 plus R. So if you're going to go through a 120% increase, so your new price, markup price, let's label that, mark up price, we find by taking the original price, C, and multiplying it by 1 plus R. But R is 1.2. So that's going to be C times 2.2, or 2.2C, right? And so now this is the price we're dealing with. If it had cost $100, then it would, if we had bought it for $100, then 2.2 times 100 would be $220. We would sell it for $220, and that would make up a 120% over cost price. A pair of shoes goes on sale for 20% off. So we are going to take 20% off of this price, right? So the markup price, and so then first sale price, we can again use this formula, but now my R is negative. So my where I started is now 2.2C. That's the price before the sale, and then I have a 20% sale. So 1 minus 0.2 is 0.8. And now this is just multiplication, so I can multiply in any order that we like. So the 2.2 times the 0.8 is 1.76. So now we are selling it for 1.76 times whatever it cost us. That is what that is saying. And then goes on the clearance rack. So clearance price. So clearance price, is again going to go through another discount of 30%, right? It's not an increase of 30%, it's a decrease of 30%. So 1 plus r in this case is going to be 0.7. So now we're going to have a 0.7 for my 1 plus r, because it's going to be 1 minus 0.3, not 1 plus 0.3. And this is the price we're at started at, 1.76 C. And so if we take that 1.76 and we multiply it times 1. We multiply it by 0.7, and we get 1.232. 1.232. So our clearance price is 1.232 times the original cost. Right? So we're still making some money on this. We're still making 23.2% above the original cost. But then a customer walks in with a 10% off coupon. So the coupon price now this is my base price, 1.232, and we're going through a 10% discount. Let's see. And so then that means that my 1 plus r is going to be 1 minus 0.1, which is going to be 0.9. So now we're going to multiply that 1.232 by 0.9. And after all that, we get 1.1088, which means we are still making 10.88% profit off of the original cost times C. Okay. Express the store's profit on these shoes as a percentage of the original cost. Okay, so again, we now only want to talk about the profit, not how much we sold it for. So to figure out the profit, what we could do is take the 1.1088C and subtract what we paid for it, which is C. And so then this will give us the profit. And these are like terms. You have a C there and a C there. So we just take the 1.1088 and subtract the 1 that we don't write. And so we get 0.1088C. And then the percent, as we did in the previous problem, is we want to compare the profit to the original cost. So we take 0.1088C and we divide it by C, and the C's will cancel out, and we want this written as a percent. So 10.88%. And what that's saying is it doesn't matter if after we go through all this, we're still making a 10.88% profit on all of this. Okay, so we even after all those discounts, we still sold it for more than what we paid for it, and we still sold it for 10.88% above what we paid for it. Moving on. Suppose you purchase an 8-year bond for $5,400. The face value of the bond when it matures is $8,316. Find the annual percentage rate, the APR. So if you hadn't had that class, or this class, I'm sorry, or if I hadn't taught this class, I would have no idea how this works, right? So I expect that you did the homework, that you watched the videos, and that you know how to do these problems. Now, it turns out that when you're working with bonds, they calculate the interest that you pay using simple interest, right? And so you need to go through and figure out, okay, so what formula do I need? And so for the interest, you're going to use the simple interest formula. And the interest is the principal times the rate times the time, where I is the interest paid, P is the principal, P is the principal, R is the APR expressed as a decimal, and T is the term of the loan in years. Okay, And so again, what we have to do is figure out how much to use this formula. We have to figure out how much interest we collected, right? If you bought something for $5,400 and its face value is $8,316, you're going to be given back $8,316. Then the difference is the interest, right? So you're going to be given back your $5,400 and then some, and then some is the interest. So we're going to take the 8,000. So the interest is $8,316 minus the $5,400, and that is $8,316 minus the $5,400, and that will give us $2,916. That's how much interest we're going to collect. And so then now we know the interest in this formula. The principal, well, we know that we originally bought this thing for $5,000, so $5,400. I'm sorry, not 5,000, 5,400. The rate, we don't know. But we do know that it's going to be for a time of 8 years. And substituting all that information into this formula, so we have $2,916 is equal to the principal, $5,400, times the rate, which we don't know, times the time, which was 8 years. So 2916 is equal to, the only operation that is present here is multiplication. So we can take the 5,400 and multiply it by 8. Gives us $43,200 times R. And then to figure out what R is, we can divide both sides by 43,200. And so then the 2916 divided by the 43,200 is 0.0675 is your R. That is an annual interest rate that should be written as a percent. So your R is equal to 6.75%. The decimal point always moves over 2 places. Putting it there, 6.75%. So you need to know what formula to use and when to use it. Okay, so you needed to know from reading from this problem that bonds are calculated using simple interest. That's pretty much, as far as I know, in real life, the only thing that uses simple interest. Your bank accounts, your checking accounts, your credit cards, all that is compound interest. Between 1990 and 2010, the average annual inflation rate was 3.5%. So things are becoming more expensive at a rate of 3.5% from 1990 to 2010. That is what that's saying. Find the salary in 2010 dollars that would be equivalent to $25,000 salary in 1990. Okay, so again, this is not simple interest. Every year that goes by, things are becoming 3.5% more expensive, and so then so your base is changing every year, and so that is compound interest. And so you need to know what formula you need for that. And so then here is your compound interest formula. F is equal to P times 1 plus P to the T, where F is the future value, P is the principal, what we started with, little p is the periodic interest rate, and T is the number of times the interest is compounded. Right? And so this is all annual. So here, little p and r are the same thing because you're only doing this once a year. And little t is 10 years, right? So f is what we don't know. Capital P is how much we started with. Find the salary in $2010 that would be equivalent to $25,000. So we're started with $25,000, and if we just want to have the same buying power, right? That's what this is implying. You would hope to be doing better in 10 years than you are right now, but you would really hope not to be doing worse. So we're just staying even. So P is $25,000. Little p is the interest rate, but that's the 0.035. Be careful with your percents. The decimal point always moves over 2 places. It's right here, right now, 1, 2, so you got 0.035. And then t, the number of compoundings. You're doing this once a year. You're doing it for 10 years, from 1990 to 2010. And so then t is 10 years, right? And so then it's just a matter of setting this up, plugging in everything that you know. F is equal to 25,000 times 1.035 raised to the 10. And no need to show any of this work. That would take you all day. We're just going to make sure that you know how to use your calculator. If you don't know how to use your calculator before you take the test, Google it, how to use your particular calculator to plug in stuff like this. Okay. And so what my calculator tells me is that this is $35,264.97, rounded to the nearest penny. It doesn't say what to round it to, so I am free to use my best judgment, and since we can go all the way to the nearest penny, we'll go to the nearest penny. And there we go. What should your monthly contribution be if your goal is to have $500,000 in your retirement savings account after 40 years? Assume that the APR is 6.6% compounded monthly, and that the contributions are made at the end of each month, including the last month. Okay, so again, you need to know what formula you're going to use. What should your monthly contribution be, so you are not going to just take a sum of money, leave it in the bank. Every month you're going to be contributing more and more money to it. But your goal is to have $500,000 in your retirement savings account after 40 years. Okay, so again, you have to know which formula to use, and that's this formula. Retirement savings formula, monthly contribution. So V is equal to M times 1 plus R over 12 to the T minus 1, all divided by R over 12. Here, M represents the monthly contribution at the end of each month. T represents the total number of monthly contributions. R represents the annual interest rate expressed in decimal form. So V represents how much we're going to have in the account for our retirement, and we know that. What should your monthly contribution be if your goal is to have $500,000? So that makes V equal to $500,000. Okay. M is what we don't know. Okay. Our annual interest rate is 0.066. Be careful, you need 2 decimal points on there. I'm sorry, you need to move the decimal point over 2 places, 0.066. And T represents the total number of monthly contributions. So we have 40 years, but it's 12 times per year because we want the number of contributions, not the number of years. So 4 times 12 is 48. You're going to make 480 payments. Okay, and then we're off to the races. Just plug this in. So V, 500,000. Is equal to M, we don't know. And then parentheses 1 plus 0.066 divided by 12 raised to the 480 minus 1, all divided by 0.066 divided by 12. Okay. Next, we're just going to realize that this right here is just a number, and we're going to figure out what number that is by plugging that into the calculator. So parentheses 1 plus 0.066 divided by 12, close the parentheses, raise it to the 480 minus 1, and then we can hit enter and get 12.91220498, and then divide that by parentheses 0.066 divided by 12. And what my calculator tells me is 2,347 and 67 cents. Okay, times M. Don't forget the M. That's still there. And then the 500,000 is still here. And then we divide both sides by the 2347.67. And so we get 500,000 divided by, and according to this, then your monthly payment will be $213, rounded to the nearest dollar. You want to have $500,000 ready for retirement in 40 years. You'll need to contribute $213 every month for 40 years. Now, if you take $213 and you multiply it by the 480, then you will have contributed 102,240, and your 2,240 would become $500,000. So you would have made an extra $400,000 just in round numbers. A couple catches with that. One is 6.6% interest rate right now is kind of tough to find, secure anyway. The long-term average of the stock market is 8%. So if you put some money there, you might be able to get better than 6.6%. But if you make that budget and say, this is, I'm not pulling this out for any reason, and stick to spending what you're allowed to spend, when retirement comes around, you'll have some money there ready to go. Suppose you purchase a car and you are going to finance $14,500 for 36 months at an APR of 6% compounded monthly. Find the monthly payments on the loan. And so people always ask when I'm teaching the algebras and sometimes even the calculus, what is this good for? And, you know, my either sarcastic answer is to do well on your test next week, or my non-sarcastic answer is these are mental push-ups for your brain. It's helping develop your brain and make new neural networks that weren't there before, and allowing you to really build your brain so that you can solve problems. But the nice thing about this stuff is you can see that if you were going to do this before you go to buy a car, you would know what these payments are, so you wouldn't let them confuse you with haggling over the monthly payment. You should discuss and negotiate. You should negotiate the final price, not the monthly payment. And that helps if you can figure out the monthly payment on your own. So suppose you purchase a car and you're going to finance $14,500 for 36 months at an APR of 6% compounded monthly. Find the monthly payments on the loan. Okay, so the following formula, known as the amortization formula, gives the monthly payment M on a loan with principal P, APR R, and paid over T monthly installments, right? And so here's your formula. M equals P times 1 plus P to the T, all divided by 1 plus P to the T minus 1, where P is R divided by 12 is the monthly interest rate, right? So typically what's advertised is the annual interest rate. And so then in this formula, the monthly interest rate is what we need. So M is what we don't know. We don't know the monthly payment. P is how much you're borrowing, and that is $14,500. Little p is the monthly interest rate. So you are paying 0.06 for the entire year. So you would pay a 1/12 of that for a month. 0.06 divided by 12 is 0.005. There we go. And then T is the number of payments, T monthly installments, and we're doing this for 36 months, 3 years, so T is 36. And we are ready to go. So M, your monthly payment, which you don't know, so you just leave that as M. P is 14,500. And then P, which is 0.005, times 1.005 to the 36, all divided by 1.005 to the 36 minus 1. And so now it's just a matter of putting this into the calculator. 14,500 parentheses 0.005 times 1.005 raised to the 36, close the parentheses, divided by, but then there's 2 terms in the denominator, so you need a parenthesis with my calculator. 1.005 raised to the 36 minus 1. Close the parentheses, hit enter. And so your payment is going to be $441.11. Okay. So then we moved on to, I believe, chapter 14, and we started dealing with statistics and how to use a sample to tell us something about the population. So we went over problems like this. You want to estimate how many fish there are in a small pond. Let's suppose that you first capture 500 fish, tag them, and throw them back into the pond. After a couple days, you go back to the pond and capture 120 fish, of which 30 are tagged. Estimate the number of fish in the pond. And so there's a population parameter, that's the ratio of fish that are tagged. And so then we have tagged to total for the population. And then there's a ratio of tag to fish, tag to total for a sample. And what we're going to assume is that if it's a good sample, then the ratio should be about the same. So for the entire population, we don't know how many there are, so we will call that P or N. I think your book used the variable N. The name of the letter makes absolutely no difference, N. But we know exactly how many there are tagged in the entire population because we tagged 500 of them. And in our sample, we go back and we catch 120 fish and find that 30 are tagged. So the ratio of the tag to the total, these two should be the same. We could then solve this equation by cross multiplying. When you have a single fraction on each side, sometimes it's useful to cross multiply. Now 5 times 12 is 60. But this had 2 zeros and this had 1 zero. So we have a total of 3 zeros behind it. So we get 60,000. And then n times 30 is 30n. We divide both sides by 30. One of these zeros goes away. 3 goes into 6 2 times, and you have 3 zeros. So it looks like there should be about 2,000 fish. And there we go. Exercises, we went on to the next section, section 14.2. Exercises 21 through 24 refer to the following story. The 1,250 students at Eureka High School are having an election for homecoming king. The candidates are Tomlinson, captain of the football team, Garcia, class president, and Marsalis, member of the marching band. At the football game, a week before the election, a pre-election poll was taken of the students as they entered the stadium gates. Of the students who attended the game, 203 planned to vote for Tomlinson, 42 planned to vote for Garcia, and 105 planned to vote for Marsalis. Describe the sample for this survey. So 21A. Let's figure out how many there were. We had 203, 42, and 105. So we had 350. So describe the sample for this survey. 350 students who attended the football game. That's our sample. Give the sampling proportion for this survey. So part B, the sampling proportion, right, is we had 350 students and there were 1,250 students. There were 1,250. So 350 divided by 1,250. So the sampling proportion is the percent of the students that answered the poll, and this was 28%. Okay, so when I punch this into my calculator tells me 0.28. I move the decimal point over 2 places, and I get 28%. Name the sampling method. So we went over several different types of sampling methods, but here we only went to the football game. And that's probably where a lot of students are going to show up. So that's just convenience sampling. Okay, so 23. Compare and contrast the population and the sampling frame for this survey. So the population is the 1,250 the 1,250 students. But the sampling frame was only those who were students who attend the football game. Not all students attend the football game. Now, they may be there for different reasons, so I don't think it's fair to say football fans, but they may be there to watch the marching band or just to socialize. But you're only going to catch people who attend the football game, and not everybody catches the football game. And so then you're leaving out a large portion of the population. Is the sampling error a result of sampling variability or of sample bias? Explain. So 23B, the sampling error, which we don't know that there is yet, but in 24, we will see that there is sampling error. That's the difference between your actual population parameter and your sample statistic. And so this is totally sample bias because we took a convenient sample at a place where not all the students go, right? So sample bias. This is sample bias, not all students. Keep it as simple as possible. Not all students go to the game. Okay. And then 24, give the sample statistic estimating the percentage of the vote going to each candidate. Okay, so of the students who attended the game, 203 planned to vote for Tomlinson. So for Tomlinson, seems like he was going to get 203 out of 350. So from this sample, we would expect that 203 divided by 350, that 58% of the people would vote for Tomlinson. But again, if you just pay attention, he's the quarterback of the football team, and you asked people at the football game, so it's not surprising that he's going to have a high number of people voting for him, especially if he's having a good season. 42 plan to vote for Garcia. So 42, Garcia got 42 out of the 350. 42 out of the 350. He only got 12%. And then Marsalis, who was also performing that day, just as a member of the band, not of the team. So he is going to get, Marsalis got 105 out of 350. 105 out of 350. He got 30% of the vote. A week after the survey, Garcia was elected homecoming king with 51% of the vote. He only got 12% in our survey. Our survey was not very good because it was at a football game. Okay. Marcellus got 30%. Well, that's the same of the vote. And Tomlinson came in last with 19% of the vote. Find the sampling errors in the survey expressed as percentages. So for the sampling errors, right? So for Tomlinson, he got it's the actual 19% and minus the projected minus 58 divided by 19% minus 58%, not divided by. It's just a difference in percents. 19 minus 58. So 19 minus 58, negative 39%. And you would do the other ones the same way. Right? So the negative tells us that we overestimated what we were going to get. So this was for Tomlinson. For Garcia, the actual was 51%, and the statistic was only 12%. So that gives an error of 39%. We were off by 39%. And for Marcellus, we were dead on. Okay. Exercises 49 through 52 refer to a landmark study conducted in 1896 in Denmark by Dr. Johannes Fibiger, who went on to receive the Nobel Prize in Medicine in 1926. The purpose of the study was to determine the effectiveness of a new serum for treating diphtheria, a common and often deadly respiratory disease in those days. Fibiger conducted his study over a one-year period, May 1896 through April 1897. In one particular Copenhagen hospital, new diphtheria patients admitted to the hospital received different treatments based on the day of admission. In one set of days, called them even days for convenience, the patients were treated with the new serum daily and received the standard treatment. Patients admitted on alternate days, the odd days, received just the standard treatment. Over the one-year period of the study, 8 of the 239 patients admitted on the even days and treated with the serum died, whereas 30 of the 245 patients admitted on the odd days died. Describe specifically as you can the target population for Fibiger's study. So the target population who we're interested in finding something out of, something about is people suffering from diphtheria. Right? Describe the sampling frame. Right? So we're not going to get everybody who's suffering from diphtheria. We're only getting the people who are coming to the hospital, and only the Copenhagen hospital. People who attended this hospital. 50A. Describe the sample of Fibiger's study. So we had 239 on the even days, and we had 245 on the odd days. 484 patients. 484 patients from this hospital. Okay. Is selection bias a possible problem in this study? Explain. So it seems as if you came in on one day, you got the treatment. If you came in on the odd days, you didn't get the treatment. So it does not seem like there's any bias possible unless you knew somebody and you told them, hey, you might want to show up on an odd day, but there's no reason to believe that that's going on. So we'll go ahead and say no, appears random. No, comma, appears random. Describe the control and treatment groups in Fibiger's study. The control group is the patients not receiving the serum. Patients not receiving the serum. And the treatment group is those that were. Those that received the serum. Okay. And then 51B. What conclusions would you draw from Fibiger's study? Explain. Since only 8 out of the 239 people died, whereas 30 of the 245 patients died, it seems pretty reasonable to accept that, to believe that the serum helped prevent the death. So serum helped to prevent death because of difference in death rates. Okay, good enough. Then we went on to 15, and in chapter 15 we talked about some different types of charts. In exercises 11 and 12, refer to the bar graph shown in the figure 15.5, describing the scores of a group of students on a 10-point math quiz. So this is a bar graph. A bar graph associates a bar with every value here, and here the values represent the scores, and the height of the bar represents the frequency, the number of students that got that score. And so how many students took the quiz? Well, we just add up the frequencies. 4 got 3s, 6 got 4s, 7 got 5s, 5 got 6s, 6 got 7s, 8 got 8s, 2 got 9, and 2 got 10. 2 got 9. Got to be careful when you're doing that. And 2 got 10. So 10, 17, 22, 28, 36, 38, 40. So it looks like 40. What percentage of the students scored 2 points? So even if you don't see a bar there, that means that there was 0. So 0%. Nobody scored 2 points, and so 0% of the people scored 2 points. If a grade of 6 or more was needed to pass the quiz, what percentage of the students passed? I can't stand this percentage. It's what percent of the students passed is what it should say. Round your answer to the nearest percent. And then it says round your answer to the nearest percent. All right. So what percent of the students passed? You needed a 6 or more. So what do we have getting a 6 or more? We have C. We have 5 plus 6 plus 8 5 plus 6 plus 8 plus 2 plus 2. And there were 40 students altogether. And so then those two make 10, and then 15, 21, 23. So we had 23 out of 40 students pass. Divide that, 23 divided by 40, 57.5%. And we are good. Then we went on to section 15.2. We talked about mean, median, and then the 5-number summary and percentiles. So here we go. Find the 5-number summary of the data set, right? So the 5-number summary is we give the minimum number. Well, let's do this first. The first thing we should do is we should write this set in order. So if you look through there, the smallest number is -6, then -5, then -3, then 2, then 4, and then 7, and then 8. Then you have another 8. And that was it. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the minimum is your first of the 5-number summaries. Your minimum is the smallest number, -6. Then your Q1 is the number that sits at the 25 percentile. And again, what you do is you take 0.25 times, there's 8 of them. A quarter of 8 is 2. And because that's a whole number, you're going to average what's in the number 2 and what's in the number 3 position. So -5 plus -3 is -8. Divided by 2 is -4. So -4. Your Q2, which is the same thing as your median. And half of 8 is 4. And so since that's a whole number, 1, 2, 3, 4, you're going to average 4 and 5. 2 and 4 is 6, divided by 2 is 3. And so that's 3. Your Q3 is your 75th percentile, so 3/4 of 4 is, 3/4 of 8 is 6. But since that's a whole number, 1, 2, 3, 4, 5, 6, that is, then you're going to average the 7 and the 8, which is 7.5. Right in the middle of those is 7.5. And then your max is 8. And so then there you go. So then draw a box plot for the data set. For your data set, you're going from, you draw a number line, you're going from -6, Had you used a scale of 2 or 3, that would have been fine too. But I just went ahead and went up by 1 just to make it easier. So my box plot, I put bars at the end, at the max and the min and the max. And then I also put a bar at Q1. Q1 is -4. At the median, which is 3. And at Q3, which is 7.5. I draw a box connecting these 3. And then I draw whiskers here connecting the Q1 with the minimum and the Q3 with the maximum. And that is my box plot. That's how you draw a box plot. Okay, so homework. The homework is due today. Test on Monday. It'll be through. It'll go over these sections, and then I will get that back to you by Wednesday, and it'll have your overall grade on your test, and then you can decide whether you wish to take the final or not. The final will be the following Monday, I believe. That is it.